And then as they get completed, they get merged back. Oh, wait, I know. Okay, the develop branch is what the developers are working on, and that's where they pull their feature branches from. But as you can see, it's a little bit complicated, right? Like, which branch do I use if I want to do something new? If I just want to try something, I need to be very aware of where exactly that's coming from. So it's a little bit complicated. And then there were a few concerns as well when it came to the branching workflow, because there is that additional overhead of constant merging across branches. Like when every time you push new code, your master has to be up to date, your release has to be up to date, your develop has to be up to date, and you have to know exactly how to merge things back and forth. And new changes are coming in all the time. So it gets quite complicated, and that adds an overhead. You can also have merge conflicts because if you're working on a feature, features can be small or large. And sometimes that can lead to much longer running branches, and that can create merge conflicts. How many people have experienced merge conflicts where you just be like, I might as well drop this and start from scratch? Right? Yeah. I see a few hands, so that makes me feel better. That's not just me. For the rest of you, it's a good thing you haven't experienced it. It's not fun. Imagine having to like dump 3 days of work because you can't figure out how to get your merge conflicts to resolve. So clearly that's an issue, as we have just seen. It's also difficult to reuse code across branches, right? If let's say two features have a similar, are trying to use similar code, people will end up rewriting it because they don't know what the other person is doing. They're working in isolation. And then finally, it's difficult to test code in a non-production environment because you can't simultaneously deploy multiple branches in an automated system. I'm sure there are ways of doing it, but again, that's another overhead, right? Trying to figure out your DevOps pipelines or your deployment pipelines in a way that will let you deploy different branches at different times. So we said, okay, what's another option? Another option is trunk-based development. Have people heard of trunk-based development? Hands, anyone who's okay? I see two people. Okay, good. People are learning something new. That makes me feel much better about the conversation we're having. So trunk-based development is a model where developers collaborate or on code in a single branch, which is called a trunk. It could be main or master in the Git nomenclature. Resist any pressure to create other long-lived development branches. So we don't do feature branching by employing documented techniques. We'll talk a little bit about that. Kind of, we'll touch on it. And therefore, avoid merge hell. Like we said, merge hell, no fun. Do not break the build and live happily ever after. Or at least as long as we can. So I've recently discovered there's a whole trunk-based development website. This did not exist a few years ago, so I was very happy to see that. But basically what trunk-based development means is all the code gets merged into one branch. There is no release branch, there's no development branch, there's no feature branch. Everything always goes into the main or the master branch. If you do need to create branches, they are often short-lived. So let's say you need to deploy a hotfix and you don't want to test it on the master, you can create a branch, deploy it, fix it, push it, get done with it. So your branches last from anywhere to a few hours to a few days at the most. There's always a single source of truth. So remember that diagram we saw with multiple branches and you don't know at what point which is the most up-to-date one? Here you don't have that problem because everything's always going into that one single branch, which is your master. And of course, that means everyone always has visibility on what other people are doing because everything's being merged back to master. There is easier reusability of code across different features and across different development teams even. Now, of course, this in itself also has a few concerns, right? Nothing's foolproof. So one big concern or one big problem that happens if you're using trunk-based development is if your master is broken, then you can't do anything else. Then the first priority is always to stop and fix master before doing anything else. You don't keep pushing onto a red build. You don't keep pushing onto a broken master. And the other thing, which is the slightly part of it, is that it requires special handling of work in progress code. We're saying if every commit goes back to master, how do you not break master? Right? So let me take a breather here. Any thoughts on how you would do that? How do you ensure that you still continue committing and pushing to master all the time, but it doesn't break if you have work in progress code? Could be something you've used, could be a brand new idea you've heard of. That's a good one. But how do you write tests for something that is incomplete? Like your feature is still incomplete, which means stuff might still be broken. But yes, that's a good point. You should always write tests. Yes. Feature flags. You are right. We're going to be talking about feature flags. So, also called as feature toggles, feature switch, lots of different names. Feature toggles essentially are a technique where you can modify system behavior without changing the actual underlying code. Now, what does that mean? I will talk about that in just a second. But to read the definition here, they fall into various categories, and it's important to take that categorization into account when implementing and managing toggles. That's just Martin Fowler saying his stuff. But basically, the idea of a feature toggle is it's a switch. It's a simple switch in your code which lets you turn features on and off as and when you want. So, for example, okay, first let me talk about this. So what it does is it separates your development and your deployment concerns. So for example, your development environment, everything's always on by default. So even if it's broken, even if it's work in progress, it's still there. In your deployment environments, you only turn on things that are 100% complete, that are tested, you have test coverage over it, everything's working as expected. Feature toggles give you, like I said, the ability to turn features on and off selectively across different environments. And I hopefully have a diagram that will show you how that would work. And it gives you the ability to test work in progress features across different environments. So if you think back to the sort of diagram I had about our different committing systems, right? It's very difficult if I want to have a version in production, which I know works, but I want to have a different version in my test environment, which has some additional features that I don't want going into production. So by using feature toggles, I can continue doing trunk-based development. I can just make sure that I'm managing my features correctly. So this is essentially a very simplistic way of doing it, right? So you have these different environments. You have a development environment, you have a test environment, you have a production environment. Each environment has a... Does it have a laser? It does, but I can't see it on the screen. Never mind. Each of them has like this config file, for example, which lets you manage your feature toggles and whether they're on or off. So in my dev environment, all my features are on. So this is work in progress code. All the developers always have access to the latest working copy of the code, including things that are work in progress. In my test environment, feature 3 is off because it's still work in progress. It's not complete. It's not ready for the QA team to test. But feature 1 and feature 2 are ready for them to test, so they are turned on. And in my production, I'm only pushing feature 1, which is complete. It's tested. Everything works. Feature 2 and feature 3 are turned off in production. Users will not see feature 2 and feature 3 at any given point of time in the production environment. So I'll talk about CD in a bit, but let's go back here. So what this will do and how this will work is you can manage it using environment variables, for example. You can manage it using config files. You can manage it using query parameters. And hopefully, if we have time, I have a demo for that as well. But the idea is that at any given point of time, there is one single source of truth, irrespective of which feature is going into production. That is a configuration-based thing only. Think of, let's say, a mobile app, right? Probably most of you know that iOS development, when it comes to pushing your apps to the App Store, can be a pain, right? Which means that if you need to fix things quickly, you need to push out features quickly, it's a bit of a pain if you have to keep trying to go through the app verification process on the App Store. So if you're using a feature flag and let's say your the only thing that's different is your app screens, what you can do is you can build all your app screens, turn it off using a feature flag, deploy the app, it's there, and then you turn on the feature toggle from the back end once your entire backend code is ready. And then without having to go through the entire App Store verification process, you have the feature available for your users. It makes life much easier than having to do this over and over again. It also gives you the ability to have different versions of your application across different environments. Exactly like this, right? The dev version of your app or your code looks very different from the one in prod, because lots of things are not available. Certain screens are missing. Certain APIs are not available. Again, there are different ways of doing it. You can add feature toggles at any level. You can add it at the topmost level where you just turn it off in the UI. You can add it at the bottommost level where you make sure those APIs are turned off. Or you can add it somewhere in the middle, depending on what feature you're trying to deploy. Now, the thing to keep in mind about feature toggles, though, is that they always have to be short-lived. You cannot have a feature toggle that's been there for like 2 years, because at that point, it's no longer a feature toggle. It probably means you need to reprioritize how you develop your features. They're short-lived only for the time duration of when you need to make sure work in progress code is hidden from your production environment. So that is one way how you can do things like continuous delivery or continuous deployment. These two, same, but different. So CD, which is continuous delivery and continuous deployment. Continuous delivery is the practice by which every commit that passes through the pipeline is deployable to production. So potentially, at any given point of time, you could push to production. Continuous deployment, on the other hand, is a practice by which every commit that passes through the pipeline is deployed to production. So it's fully automated, no manual intervention. Everything that goes into master will go into production. Now, I do understand and recognize that this doesn't always work. What I've shown you is, one, an oversimplified version of how software delivery happens. Two, there may be situations where it's just not possible to have every commit going into production, but it's an ideal situation. It's something to aim for, right? And we have done it on my teams before. I promise you, it works. It's just slightly more it's a learning curve. It starts off very steep, but once you get there, once your setup is in place, makes your life super easy. Just sort of how the value map looks like for when you're using either continuous delivery or continuous deployment. You have your source code. So this is a scenario when you have like a multi microservices kind of setup, right? So you have your different repositories where your source code lives. All of this, then you have your individual build stages for each services. All of this then gets packaged together, goes into where you can run maybe your integration tests, for example, ensuring that everything works well together now that it has worked well individually. You can have multiple test environments after that. So you can have your QA staging, UAT, pre-staging, pre-prod, whatever, however many you want, right? And as you can see, there's like an environment and app config that like a database that runs across all of these. So you can say, my QA, this is my config, my staging, this is my config, my production, this is my config. And that's a great place to put your feature toggles, for example. And then once all of this, you can deploy different things across different test environments. Then you can put everything into a staging and then potentially production environment. You can have as many stages here as you want, right? But the idea is that all of this can be automated. All of this can run every single time you deploy or you push a commit into master, which may beg the question, so wait, what if I am committing 50 times a day? Yeah, you're deploying to production 50 times a day. It's great, right? You never have to worry about production releases and you're like, oh, we have a release tomorrow. The world is going to stop. We have to make sure nothing code freeze and whatnot, right? Don't have to do any of that. There are ways of ensuring that there is no system downtime, which is a completely separate conversation. But there are strategies and techniques that ensure that you have no system downtime when you're deploying to production 50 times a day. Now, why would you use CD? Which is the big question, right? I've talked about all of these different things, all these different practices. Why would you do it? One, it ensures better quality code because everything is always going into the same same branch in your master branch. Because everything is potentially deployable to production any given point of time, as developers, we're much more aware of what we're pushing. So we ensure everything's well tested, maybe practicing test driven development, maybe practicing behavior driven development, all these different techniques that you have to ensure better quality code because you only want to push the best to production. It gives you faster feedback across environments. So if something doesn't work, you know as soon as it hits your first environment saying, oh, wait, that's not how this was supposed to function. And you have the ability to fix your mistakes faster rather than waiting until something reaches, I don't know, your staging or UAT or even your production, then realizing, oh, wait, it doesn't work. Which again is super, because then you have to make sure your configurations are consistent. You have to make sure your servers, the setup of your servers is consistent. All of these different things do come into play. There's no more manual intervention from deployments. If you're using continuous deployment, no more manual intervention. You can go to sleep easy at night knowing that you didn't break anything because everything's working as expected. If something breaks, your tests are going to catch it. Your integration tests will catch it. Something somewhere will have caught it already. And you know that you're pushing what is the best version of your code into production. All right. I think that is all I had. Thank you for listening. Oh, I'm happy to answer any questions. I know I just sort of barreled through everything. Michael, do I have 5 minutes for a quick demo? Okay. While I prep that, if there are any questions, happy to take them.
Demo time. Hey, wait, later I may quiz you. What is CI/CD? What is CD? Okay. Okay, fine. Whatever.
Wait, this is CI. That's it. Now you know CI.
Continuous integration. Okay.
All right. Let's see if I can actually do this.
Font's a bit small though.
Okay, I don't need the...
Oh, okay. In the camera?
So, super simple, okay? Please don't judge my CSS skills here. I don't have CSS skills. And also it says Worksdays SG 2019 because that's when I actually built it. So, welcome to Worksdays. That's not where we are. Welcome to Junior Dev. I should have changed that. Clearly, I didn't think this ahead. But just an example, right? So here is my home page where I say my feature 1 toggle is off, my feature 2 toggle is off. What you see is something like what you would see in a production environment, right? Now I go to my localhost 3000 and say, okay, I think it's called features. Let's see, not called features. What's it called? Feature toggles? Yeah, it's called feature toggles. Okay. So in my case, I have a very simple UI where my features are controlled by checkboxes, for example, right? In this case, a simple JavaScript app, nothing too fancy. So for me, a UI feature hidden page in my UI works. So let's say, okay, I want to turn on my feature 1. I say update, something happens here. Now, when I go back and refresh my page, I see a bar there that says, okay, feature 1 is now on. It's as simple as that. Now, if I go back and turn on my second feature toggle and I go refresh my homepage again, feature 2 is also on. So now I can selectively turn them on and off. So let's say in my dev environment, I want to test what happens when feature 1 is on and feature 2 is off. I say, okay, cool. Just go there, update it, and I see exactly how my homepage reacts. Didn't have to make any changes, didn't have to restart any servers, didn't have to do anything, but I know that my app works irrespective of which features there and which features not there, just as expected. So that was a very, very simple look of how you can manage feature toggles. Like I said, you can do it via UI. We had a project where we built a hidden page that only the admins could access via a password where they could then turn off features, feature toggles on and off. We had one where we used query parameters. So you would just go to the page and say, okay, feature XYZ equals true. It won't work here, obviously, because I haven't configured that. But you would just do that and your feature would turn on because we're picking it up. We're turning it off via the UI, for example. There were others where, like I showed earlier, you have a config file in each environment. So there are different ways of doing it. Java now has a library which you can use for feature toggles. I think it's called Toggles with a Z, or Feature Toggles with a Z. Lots of other languages have stuff like this built in. So I would say give it a shot, try it. Maybe it'll work for you. If not, there are plenty of other options that you can use, but that's something I wanted to share. So thank you very much.
Thank you, Isha. Does anyone have any questions for Isha?
Yes. I see a hand at the back.
Is that a hand? Wait, I'll run.
I mean, what is the overhead? Because we said it's short-lived, right? So what is the overhead of keeping a toggle and removing the toggle when you're gone live, and if it's a complex feature?
So given it's all in... Sorry, I should use a mic as well. Given it's all living in a config file, right? It's as simple as removing that line from your config file and removing the code from... Your code will... Honestly, just like the simplest of things, it's literally an if-else block. If feature toggle on, do this, else do this. So, no, but that's the thing. As a developer, you know where your feature toggles are. You know which feature you're working on, which you've turned off or turned on. So once it's gone live, once it's in production, next time you start working on a feature, first step is you go remove your previous feature toggle. I've done it. I promise you it takes 10 minutes of your time at most, because you're doing it feature by feature. You're not doing it all features in one go.
I think it cannot be if I go to feature 2, I remove feature 1, right? It should be when I go live. Because if my first feature is still only in dev, my second feature is only in QA, I still have to keep them.
You have a feature toggle per feature. So when your feature's gone live, let's say feature 1, right? Your feature 1 goes live, you remove the toggle for feature 1 and you remove the block of code that was non-feature 1. Yeah. It's literally deleting lines of codes. And if your code breaks then it means you didn't implement the feature toggle correctly.
Yeah.
It is a learning curve, I'll promise you that. Yes.
So, but that's an overhead is what I feel.
Depends on your definition of an overhead. For me, I love deleting lines of code. So... You're telling me I'm forced to delete lines of code every time I start working on something new? I'm very happy. And like I said, it takes 5 minutes.
It's not on starting on something new. It's when you're gone live. So you have to track like when I've gone live and then...
So maybe that's where my experience is slightly different. When I was writing code, you don't start on something new until you finished what you were already working on. So... The thing is, you do see something to production. Yes, you're right. Some things in testing, I start on my new story, right? Correct. But the idea is, anyway, you're pushing everything to production, to master, right? So all you have to do is, while you're working on your day-to-day thing, you have one commit in the middle, which says removing feature toggle for the last feature. That's it. And it's still, everything's going into production. Everything's working as expected.
And if the same feature involves multiple developers, they have their own toggles, right? So
they use the same toggle. They will use the same toggle.
They'll use the same toggle. Okay.
They will use the same toggle.
Usually, as an agreement with the team to use one particular toggle for this particular epic. Okay.
That's why it's called a feature toggle and not a developer toggle. That was a bad joke. I don't know why y'all are laughing.
Feature toggle. That's a good joke.
Really?
Yeah.
Thanks, Michael.